The building and construction sector is one of the largest consumers of raw materials in the world. In 2022 alone, buildings accounted for 34% of global energy demand. They were also responsible for more than a third of the world's total waste and nearly 40% of global CO2 emissions. We are quite literally building the climate crisis. But it doesn't have to be this way. The circular economy offers a powerful alternative, one built on principles of reuse, adaptability, and regenerative design.
Sounds promising, right? But let's be honest, we talk a lot, we publish strategies, we set targets, yet when it comes to real practice, we still fall short. Hello, my name is Askar. I'm a researcher in sustainable construction and circular economy. Over the past years, my PhD journey has been dedicated to one challenge. How do we turn circularity from a bold idea into a real design decision?
What I'm presenting today is the outcome and the ongoing progress of that effort. It's called CIRLA-B, a multi-criteria assessment model integrating circularity and lifecycle indicators in buildings, both as a standalone framework and as a BIM-embedded tool. CIRLA-B is in essence a circularity lab. It allows design teams to test project scenarios, compare design alternatives, and evaluate performance across 4 composite circularity indicators. The development of CIRLA-B began with a clear ambition to translate circularity principles into actionable design intelligence. This started by defining lifecycle system boundaries and mapping material flows across all phases of a building's life, from extraction to end of life. More than 40 circularity criteria were identified and structured into a matrix that bridges 2 key dimensions: the physical layers of a building, structure, skin, space, plant services, and the levels of intervention from systems and components down to materials. To move from structure to synthesis, fuzzy scoring and mathematical modeling were applied to build 4 composite circularity indicators. These were then integrated with 2 LCA metrics, embodied energy and embodied carbon, using Prometheus 2 method to support balanced multi-criteria decision-making. The result was a functional prototype in Excel, tested through real scenario simulations. It proved one thing: circularity can be operationalized, not just discussed.
But if circularity is to become standard practice, it must move beyond theory and into everyday tools used by design teams. That's why the second stage of this work focuses on digitalization.
CIRLA-B is now being embedded directly into the BIM environment through a custom plugin built in Revit using PyRevit and Python. The plugin is being developed to automatically extract design data, evaluate connections and parameters, and deliver real-time circularity scores based on the 4 core indicators, all within a single click. It allows for live, contextual feedback during design, making circularity not just measurable, but actionable.
If we want to build sustainably, we must design with the end in mind. CIRLA-B is not just another study, it's a tool to put circularity into action, one that helps turn EU strategies into real design decisions. It's a step toward the practice and the circular built future we can start shaping today.